Section 1. Air masses. Difference in air pressure are caused by unequal heating of the Earth's surface. The region along the equator receives more solar energy than the regions at the poles. The heated equatorial air rises and creates a low-pressure belt. Conversely, cold air near the poles sinks and creates high-pressure centers. Differences in air pressure at different locations on the Earth create wind patterns. How air moves. Air moves from areas of high pressure to areas of low pressure. Therefore, there is a general worldwide movement of surface air from the poles towards the equator. At high altitudes, the warmed air flows from the equator towards the poles. The temperature and pressure difference on the Earth's surface creates three wind belts in the northern hemisphere, the three wind belts in the southern hemisphere. The Coriolis effect, which occurs when winds are deflected by the Earth's rotation, also influences wind patterns. The process that affects air movement also influences storms, such as the one shown in Figure 1. When air pressure differences are small, air remains relatively stationary. If the air remains stationary or moves slowly over a uniform region, the air takes on different characteristic temperatures and humidity of that region. A large body of air throughout which temperatures and moisture are similar is called an air mass. Air masses that are over frozen polar regions are very cold and dry. Air masses that form over tropical oceans are warm and moist. Types of air masses. Air masses are classified according to their source regions. The source regions also determine the temperature and the humidity of the air masses. The source regions for cold air masses are polar areas. The source regions for warm air masses are tropical areas. Air masses that form over oceans are called maritime, and air masses that form over land are called continental. Maritime air masses are moist, and continental air masses are dry. Air masses and the symbols used to designate them are listed in Table 1. The combination of tropical or polar air and continental or maritime air results in air masses that have distinct characteristics. Continental air masses. Continental air masses form over large land masses such as northern Canada, northern Asia, and southern United States. Because the air masses form over land, the level of humidity is very low. An air mass may remain over a source region for days or weeks. However, the air mass will eventually move into other regions because of global wind patterns. In general, continental air masses bring dry weather conditions when they move into other regions. There are two types of continental air masses, continental polar and continental tropic. Continental polar air masses are cold and dry. Continental tropical air masses are warm and dry. Maritime air masses form over oceans or other large bodies of water. These air masses take on characteristics of water over which they form. The humidity in these air masses tend to be higher than that of continental air masses. When these very moist masses of air travel into a new location, they commonly bring more precipitation and fog, as shown in Figure 2. Two different maritime air masses are maritime polar and maritime tropic. Maritime polar air masses are moist and cold. Maritime tropic air masses are moist and warm. North American air masses. There are four types of masses that affect weather of North America. Come from 6 regions. These air masses, their source locations, their movement, and the weather they bring are summarized in Table 2. The general direction of the air masses movements are shown in Figure 3. An air mass usually brings the weather of its source region, but an air mass may change as it moves away from the source region. For example, cold, dry air may become warmer and more moist as it moves from land to warm ocean. As the lower layers of air are warmed, the air rises. This warmed air may then create clouds and precipitation. Tropical air masses. Continental tropical air masses form over deserts of the southwest United States. These air masses bring dry, hot weather in the summer. They do not form in the winter. Maritime tropical air masses form over warm water of the tropical Atlantic. They bring mild, often cloudy weather to the eastern United States in the winter. In the summer, they bring hot, humid weather and thunderstorms. Maritime tropical air masses also form over warm areas of the Pacific Ocean. These air masses do not usually reach the Pacific coast. In the wintertime, maritime tropical air masses bring moderate precipitation to the coast and the western deserts. Polar air masses. Polar air masses form three regions. Polar air masses from three regions: northern Canada and the northern Pacific and Atlantic Oceans influence weather in North America. Continental polar air masses form over ice and snow-covered land. These air masses move into the northern United States and can occasionally reach as far south as the Gulf Coast of the United States. In summer, the air masses usually bring cool, dry weather. In the winter, they bring very cold weather to the United States. Maritime polar air masses form over the North Pacific Ocean and are very moist, but they are not as cold as continental polar Canadian air masses. In the winter, these maritime polar Pacific air masses bring rain and snow to the Pacific coast. In summer, they bring cool, often foggy weather as they move inland and eastward over the Cascades and the Sierra Nevadas and the Rocky Mountains. These air masses lose much of their moisture and warm slightly. Thus, they bring cool and dry weather by the time they reach central United States. Maritime polar Atlantic air masses move generally eastward towards Europe, but they sometimes move westward over New England and eastern Canada. In winter, they bring cold, cloudy weather and snow, as shown in Figure 4. In summer, these air masses can produce cool weather, low clouds, and fog.